Hi, all. Thank you for your time. And what I have for you all today is the capability I developed called Vector, which stands for Vulnerability Evaluation, Control, and Targeted Orchestrated Remediation. So, what is Vector? Vector is a multi stage AI system that closes the gap between finding a vulnerability and fixing it. It ranks threats by real business risks instead of raw severity and have the inbuilt feature to map these risks with organizational specific context, which is unique to every organization's technology and application stack. This capability tests fixes in a sandbox before they touch production ecosystem and only files a ticket once human signs off. For an enterprise security team, which is drowning in thousands of findings of vulnerabilities, Vector can work along as a team member and perform automated ingestion of n number of vulnerabilities across code, infrastructure, and application stack. And it then takes that data, performs enrichment, and applies custom context that is unique to every organization based on how their application systems behave. As you can see within the image over here, we have multiple sources from which the vulnerability data is being ingested, which is then normalized and stored in a repository such as a data lake as of now. For the demo purposes, I'm using SQLite data lake, but it could be a cloud data lake on GCP platform. We also have a scrubbing layer where all the sensitive information associated to these vulnerabilities are scrubbed away, which means asset associated with a specific vulnerability gets scrubbed away so that the information when being passed to the LLM models such as Gemini on cloud or local LLM models such as Gemma, when they are processing that information, we are not sending out the IP address or the host name, only the CV for enrichment. Now, this model also works on the principle or the architecture, distributed architecture of agentic AI from Google, where I'm leveraging multiple AI agents to perform various tasks such as enrichment sub-agent, sandbox, remediation, and ticketing, and assembly report. We also have a human in the loop gateway where once the information is being processed, verified, validated, tested, and ready for remediation, a ticket can be filed. And we also have multiple integrations enabled within this system that we can integrate it for ITSM solutions such as Jira, ServiceNow, so on and so forth, depending upon what the organizations or clients are using. So, with further ado, let me jump quickly into getting this system up and running so I can walk you all through some of the features that I have built into it. So quickly bringing up the local Olama system. While that comes up, I'm just gonna open another PowerShell and make sure that my web server is up and running as well. Uh, okay, and let's bring the web server up as well. And the moment it comes up, you're gonna observe that. Okay, this is the dashboard for the vector. Again, I haven't built all bells and whistles into it, but this is essentially what we are supposed to see, in terms of what the vulnerabilities within our ecosystem are that are associated with code, with application, or at an infrastructure level. Now, I'm using a dummy data to showcase the capability, but essentially the hooks and the configuration do exist to ingest live data from Google Cloud Platform assets as well. Uh, this is an overview where it shows the asset information and the associated vulnerability, the environment that they are in. Now, moving on to the asset inventory, it kind of gives us the option of what ecosystem our asset is in, whether it's in prod, non-prod, staging, dev. Gives a few uh, options to select the severity of a vulnerability associated with an asset. For example, I can choose uh, production system, and then I can say show me all critical, and this is essentially the laundry list of all the assets. Now I did build in a widget, a feature or an option where I want to see, hey, how many of these assets have internet access? Just from the priority standpoint, I want to increase the priority or the criticality of, hey, this is what I'm going to focus first on. So kind of shows that as well. Again, not limited to, but just for the purposes of this demonstration, kind of build certain features as well. Now, this is where we have the visibility of all the vulnerabilities that are attached within our assets. Now, again, these vulnerabilities are coming in from sources such as your EDRs, your scanners, your cloud native services, security services, or even your CSPM solutions, whatnot. So essentially, this is where you'll see all that information. Now, you would see a column where it says enrichment not enriched because I have not run the automation pipeline right now, and hence it's not being enriched right now. So, but let me run the pipeline quickly and show you. This is where my agent kind of kicks in and starts enriching the information associated with the CVE ID. Leveraging Gemini. As you can see, it ran the enrichment module. It kind of also looked for, hey, is there any sensitive information on this asset? You can have PI or you can have any confidential information pattern included into it. So the moment it identifies those patterns, or even you can take a regulatory control framework and say, based on the controls, any information associated to. So we have the capability to write that logic where anything that you deem sensitive as per an organization can be scrubbed over here and does not go beyond the local processing of this capability. Again, going down, this is where now a mirror image of your asset is going to be replicated, and then the testing is going to happen from an exploitation standpoint, whether the vulnerabilities that were identified on an asset, do they actually exist and can they be exploited? So as you would see, the verdict is failed, which means the vulnerability exists and it is a valid vulnerability that is existing on the ecosystem that can be now exploited, right? So it kind of gives the rationale, it gives the exploitability note, and the dependency impact. Now, one thing that I do want to kind of spend a little time on the dependency impact is usually when we look at vulnerabilities associated with applications within our production ecosystem, an application server may be communicating with multiple servers within the ecosystem, right? So an application may be dependent upon its operations on multiple associated factors that may not be deployed on the same server, but communicating with other servers within its ecosystem, right? So this capability has the ability to identify those dependencies, and any change in trying to kind of patch, a remediation on a server, breaking a dependency, it can do all that identification. So essentially, it doesn't go blindly and say, oh, go ahead and upgrade this patch on a server or for an application because it's vulnerable, and then breaks the entire ecosystem from the application operation standpoint. It would identify those dependencies, and that logic is built in within the capability as well. You also get the waiting for the vulnerability and the ranking and its distribution across different categories. Again, these weight distribution categories can be customized. Pretty much everything over here can be customized depending upon what your organizational requirements are. This is where we do essentially the remediation. Now you can select how many vulnerabilities over here you want to go ahead and test for remediation. So essentially, if you identify a vulnerability on an asset and you have validated by running a pipeline that yes, it does exist within my ecosystem and it can be exploited, over here I'm going to go ahead and deploy a patch to that vulnerability. And this is where that a sandbox environment, an air gap sandbox environment, is being spin up by the agentic agent, and then it kind of tests the patch for that vulnerability, validates whether the patch is going to work or not. Once it confirms it works, it rescans it to ensure that the vulnerability is gone, it doesn't exist, and then captures that information and brings the human in the loop to say, hey, the this is how I can go and fix this, and I tested it out. Now, do you accept this remediation, or do you want to reject it? And this is where the human comes in. If I am a SOC analyst or a security person, I'll say, yeah, I approve this, submit the decision, and now this entire case information from the point of vulnerability identified on an asset to being tested for a vulnerability validation that yes, the vulnerability exists. These are the steps to remediate it. All of those steps are now captured over here, and they are very neatly captured in a ticket, which is you can have Jira, ServiceNow, or any other ticketing system over there to kind of capture that information and then pass it along to your remediational teams, who now can go and perform remediation within the ecosystem, just following along the case notes. Last but not the least, what you have are the external sources that we have built in. These are some of the native security services from Google that the integration kind of is enabled within this version of Vector. The full-fledged or the version 2.0 has more hooks and integrations available, but for the purposes of this prototype demonstration, these are some of the high level security services that are currently depicted from demonstrating the capability feature set. Again, it can be expanded upon to include CSPM, native CSPM solution, or other security solutions within the ecosystem, or even EDR, whatnot. So that's net the capability for the vector. Essentially, uh, to summarize, vector is a capability that ingests vulnerability from multiple sources, performs the automated testing and confirmation of those vulnerabilities on assets, goes ahead and performs the recommended remediation in a sandbox environment, and then captures all that workflow and information along with notes cleanly in a ticketing system of choice for an organization, so that organizations can go and perform actions in the production ecosystem. The scale of executing these vulnerability testing can be depending upon the requirements. So you can have parallel execution of these agentic AI agents running up to thousands of vulnerability testing in batch, or you can do it, you know, a funnel version up to one single asset testing as well. So it depends upon your need and requirement that you can scale it as much as you want, depending upon your need or requirement, or even go one by one. With that, I'll wrap up. Thank you. And if you have any questions, please feel free to reach out to me or DM. Happy to, sit down and have a more detailed, in-depth conversation related to this capability. Thank you for your time and have a good day ahead.